Hello, I am Rinki Chopra. I am a PhD student at IIT Bombay. Also, I am a teaching assistant for this course. So, today I am going to take a lecture on computational simulation software. So, let me start the lecture on computational simulation software. As we all know, to solve any problem in electromagnetics, we use Maxwell equations. So, Maxwell equations are basically defined in two forms, differential equations or integral equations. But to solve any complex problem, it is difficult to explain with the help of Maxwell equations. So, many numerical techniques have been defined like finite difference time domain method, finite element method, method of movement. So, finite element method and finite difference time domain method both use difference equations to solve any electromagnetic problem, whereas the method of movement, it uses the integral equation to solve Maxwell equations. So, to solve these equations on the background, many softwares have been designed like i3D, CST Microwave Studio and HFSS. i3D stands for Integral Equation 3-dimensional software. CST Microwave Studio stands for Computer Simulation Technology Microwave Studio, and HFSS stands for High Frequency Structural Simulation. So, let me now start with the basics of i3D. i3D is a field solver which solves the electromagnetic field equations with the help of integral equations. It utilizes the method of movement which is based on the Green's function, which is basically based on the weighted complex residual method. Now, let me tell about the i3D application programs and capability. Now, if you open the i3D interface, you will see many options like one is mgrid. So, mgrid is a basic major layout editor for construction of a structure. In this, basically we design a polygon, we edit polygon, we see the current distribution and such type of things. The second is the module. It is a schematic editor for parametric display and for the core circuit simulation, like if we want to simulate our antenna with the lumped elements like RLC, then with the help of module we can simulate this. Then pattern view, it is a post processor which is used to analyze the post processing parameters like current distribution, S parameters and other things. Next is i3D library. So, i3D library is used to realize the high level parameterization. The next is AGIF, that is used to generate the 3D structures in the form of cadence file. Then is line gauge. Line gauge is used to calculate the transmission line parameters. So, let us start with i3D. So, first to start i3D, we need to start i3D program manager. Now, when you open program manager, if you will click here, you can find mgrid, pattern view, module, i3D library, line gauge, MD spice and AGIF. And I have already told you what is the significance of each particular submenu in this menu. The second step, when we open the mgrid, one window pop up. In the file menu, if we want to create a new project, then we used to open the file menu, and to create a new project, just click on the new part. When you open the new part, then one window will pop up and it will look similar to this window. This is called as a basic parameter window. Now, if you see, there are many windows here. First one is comment. This is just to give the comments if you want to mention, like if you are defining any substrate like FR4, and if you want to give the details of this particular substrate, then you can mention here FR4 substrate and such type of things. Then second is length. In this, the unit is given. Here you can set different units like mm, micrometer, etc. This is minimum, the minimum length that it can tolerate, that is given. The second is the layout and grid, the resolution of the layout and grid is given. Then the enclosure part, and the next part is the meshing parameters. So, here all the meshing parameters are given like meshing frequency, cells per wavelength, and the scheme which is used to simulate, and the low frequency. That is low frequency, it means here it is given NF3 at 0.002 gigahertz. It means at 0.002 gigahertz, it is creating 3 frequency points. Then automatic edge cell. So, the automatic edge cell is used to define the meshing towards the edges. So, if we enable this particular function, then it provides finer meshing towards the edge, which is helpful in our simulation and which provides us better accuracy. Then this is mesh alignment, this is the comments related to the mesh alignments, and the next part is the substrate related specifications. The first one is substrate layer. Now if you see here, the by default 2 layers are given. So the lower one is the ground layer. If you see here, it is written z top equals to 0, epsilon r equals to 1. So this one is ground layer. Now let me show the interface first. I am just opening the M grid. So this was the option. I am creating a new projects. So here is the window. Now if you see this lowermost layer, in this if you see one window pops up. So here you need to define the specification if you are defining any substrate. So in this case, if you see for the ground substrate, it's by default its z top will be 0 and you can't modify the top coordinate of its z axis, and the epsilon r is 1 and the conductivity is very high, that is why it is ground plane. Now if you see the second layer, that shows the upper half which is air. So by default 2 layers will be selected. Now if you want to define a substrate, then you need to define a substrate. This one is to insert a layer, these two options are to insert a layer, and the third one is to delete the layer. So just to define a substrate, here you need to give the comments if you want to give the comments for the substrate, or if you want to define a substrate, then you need to define a substrate here. So let me take a substrate. Let's take the substrate is RT derived 5880 with thickness of 0.8. So my thickness is 0.8. In that case, z top should be 0.8 because the lowermost z top is 0. So it should be 0.8. The epsilon r for RT derived 5880 is 2.2. So I am putting that 2.2, and the loss tangent for RT derived 5880 is 0.001. The rest of the things will be as it is, because these are the things which are given to us for RT derived 5880. Then press OK. Now if you see one layer is created above z top equals to 0. So this is how we introduce a new layer. Now if you press OK, this is my mgrid window. Now here you can see this particular section is called as layout editor window, and this one is called as status window. Now if you can see here, if we are moving our cursor, the position of x, y and z, dx, dy, dz, these are changing. So this is showing the status of the cursor, and the dx and dy are the respective location with respect to the last point. Now if you see this section, this is called as a layer window. In this section 3 windows are given. This is corresponding to 0.8, this is corresponding to the ground layer. In this section you can check different type of layers, like in elevated mode, the whatever layer is you have selected, that will be shown on the top and the others layer will be shown on the bottom, but in actual scenario they will be on the top, in whatever way you design. Now if you want to change it, if you do not want to show the other layers, you just want to show only that layer which you have selected, then you select this option, or if you want to show other layers in the form of contour, then you can select those things. So in this way you can proceed. In the last section, this is called as the information window, and here it shows the operations that you perform plus the details of geometry and the substrate. Now here you see these 3 layers which were defined, these are given, and the metallic type, these type of details are given here. Now if you see on this window, there are multiple menus. So this menu, if you see, this is file menu. This is basically the conventional menu. Now if you want to create a project, so in the conventional file you can create the file and you can open the file, save and merge different files. So same menus are available here. You can see here, this one is new, open, save, save as, etc. The second is edit. So in the edit part you can draw the polygon, you can copy, you can paste, and you can do such type of operations. The next is parameter window. In this you can define different parameters, you can modify parameters, you can play around with the parameters, like if you want to change the color of parameter, then you can change from here, and if you want to display particular parameter, if you want to do such type of operation, then such type of operations you can do from here. The next is the input part. This input menu mainly deals with the vertex related operations. So, if you want to define the particular, if you know the vertex and if you want to define your polygon in terms of vertex, then you can use this particular menu. The next is the advanced edit option. So, advanced edit is used to accommodate the additional edit related operations. So, different menus are introduced in this particular section, like if you want to check the electrical connections, if you want to dig a hole or such type of things, you can do in this particular section. The next is entity. So, this is used to create the different type of polygons, predefined polygons, like if you see here, this is rectangle, symmetrical T junction, Y junction, etc. These type of geometries you can create from here. The next is related to port. This is used to excite the port. You can define different type of ports, you can create a port, you can change the location of port, and you can see at what location it is from the port properties, and also you can delete from this section. The next is the optimizer. Now, if you want to optimize a particular geometry, if you want to optimize a particular variable, then you need to use this particular option. The next is the viewpoint. So, if you want to change the view of this particular mgrid layout editor, then you can change with the help of this particular menu. Next one is process. In the process, you use this to simulate and to check the post process parameter, like S parameter, current distribution, this radiation pattern, and such type of things, whichever is required to process any antenna or microstrip circuits. The next is the window. So, this is used to check the different type of window, like if you want to see the geometry in different window, then you need to select this option. If you want to see the mesh view, then you need to see this option. If you want to check the current distribution part, then you need to select this option, and like that. So, that is all. So, let me see here. Now, since let us start with this particular software. So, substrate so far we have designed. Now, if we want to design any particular microstrip circuit, let us say we want to design a rectangular microstrip antenna. So, we need to have, one thing is we need to have a frequency, the second thing is we need to have a substrate. So, substrate we assume that we are using RT-Doroid 5880. So, the specifications for RT-Doroid 5880 are that epsilon r equals to 2.2, 10 delta equals to 0.0012, and thickness is 0.8, and that substrate layer we have already defined. So, we know from the conventional theory of microstrip antenna arrays, these are the equations which we use to calculate the dimensions like L and W. Now, we want to design right now, we want to design the square MSA. So, these are the equation which we will use. The frequency that we are using is 5.8 gigahertz. So, if you will calculate with the help of this equation, you put in this equation, calculate W, then you calculate epsilon effective, then you calculate delta L, and after that you calculate this L. This L is a physical L that you will use when you will start designing this particular antenna. You can also calculate these the length using the line gauge parameter. As I told you earlier that with the help of line gauge you can calculate the different microstrip line parameters. So, all you need to do is just select the line gauge from the option of mgrid, like if you see here, here line gauge is given, just open this. Now, if you see here, there are different options like coaxial line, coplanar waveguide, etc. Now, so right now we are interested in microstrip, so we just select microstrip. Here you see different options are given. You need to just give the specifications, and accordingly your effective L and W will be calculated. So, the frequency at which we are interested is 5.8 gigahertz, and this is 2.2 relative permittivity of RT-Doroid 5880, and the thickness that we were using is 0.8, and this is metal strip thickness. So, generally we take it either 0.002 or 0.004, just keep it as it is. Now, we know for the substrate it inverts its phase from one end to another end. So, it should be around So electrical length should be 180 degree. So if you calculate, it will come around this. This is approximately same as the equation we calculated. Now if you see, the calculated length was around 16.74, while in that with the help of line gauge it was around 18, and it is roughly same, not exactly same, but rough idea you can get from with the help of line gauge. So let us start making the polygon. Go to the mgrid. Now from here you see, you go to entity part, select rectangle. Now if you see here, you need to give the reference point, the center point where you want to make your polygon. So right now let us take it at center. So keep x coordinate at 0, y coordinate at 0, and we need to check at which layer we want to design. So we want to design our patch antenna above the substrate layer. So the z coordinate should be 0.8, but by default the layer selected was z equals to 0, 0. So let us select first this coordinate. Now you design. Now you can see here z coordinate is 0.8. So it will depend which layer you select, accordingly z coordinate will be shown here. So the length should be 16.74 and the width should be 16.74 to design a square MSA. Now if you see, just click on all, you can see the geometry. This is my square polygon. If you see here in this window, in green there is a dotted line. So this dotted line shows that it has infinite conductivity and it is a ground plane. Now if you design anything on this particular layer, then it will be like you are cutting a slot on a infinite ground plane, because by default it is an infinite ground plane with infinite length and infinite width. So if you are designing anything above that, so it is equivalent to that you are cutting a particular slot in that particular plane. So this is my rectangular MSA. Now so far you have designed the rectangular MSA, and the next thing is you need to excite it. So to excite it, we need to define a port. So the length in this case is around 16.74. So here we are not using any broadband technique. So the approximate feed point location should be from L by 6 to L by 4, just to give a start point. So let us take it around 2.5. Select entity, go to probe feed to patch. Then here you need to select the location where you want to provide your feed. So this is 2.5. Now y coordinate I want to keep as it is. This is a number of segments, because you are defining a probe feed that will be in the form of cylinder, and the cylinder will be decided in terms of circle. So the number of segments, the finer the more the number of segments, the finer would be the circle. So let us take it 12. Then this is a start z coordinate and end z coordinate. This will show you the layers in between you want to connect your conductor. So this should be 0 and 0.8, because 0 is my ground plane and at 0.8 we have a patch. So my conductor should be connected between these two layers, and in this case the negative level should be defined at the ground level. So it should be 0, and we need to define in between some positive level. So by default it is 0.08, so we need to just take it above the ground plane. So we may keep it as a 0.08, or we may keep it like 0.01, that should be enough. Here we are providing a coaxial feed. So in this case, since we are dealing with C band, and for this particular antenna is 5.8 gigahertz, so we will use SMA type of connector, and the radius of SMA type of connector is 0.6 mm. So let us give it 0.6 mm, put it, sorry, I could not enable this particular thing. Select, then you select this, then delete, then again entity, probe feed to patch. Last time I did not enter here, so that is why my feed location was at center. So if I entered, then this is my center position. This is 12. number of segments, start z coordinate is 0, end z coordinate is 0.8, and negative level is 0, positive level is 0.01 around, and this should be 0.6. Then press OK. Now, if you see, this is my feed point location. Now, we need to simulate it. Before simulation, we need to save it. So, let us first save it. Let us save it, square MSA. This is we have saved. Now, we need to simulate it. So, then go to process, you see here we have simulate option, start simulation. Now, if you see here we have different options. The first is meshing frequency. This frequency should be higher than the our operating frequency. So, in our case we are designing it for 5.8 gigahertz. So, let us take it around 6.5 gigahertz. So, larger will be the frequency, finer would be the meshing, but the time will increase. So, it is generally desirable that whatever is meeting your requirement, like 6.5 would suffice for our case. So, that is why I have taken 6.5. Now, the second option is automatic edge cell. Now, if you see here, automatic edge cell means that it is providing you a meshed structure, and the meshing towards the edges will be finer, which will increase the accuracy of our results. So, we need to enable it. We check here. Now, if you see the frequency we defined, that is given here, this is second option is cells per wavelength. So, this is the how many cells we are dividing per wavelength, that the information is given, and the low frequency part that I have already told you. Now, if you see here AAC layer, that is not enabled, here no is written. So, to enable it, you need to make it 1. There are different options you can see. Depending upon the accuracy, we need to select the options. Now, for like basic antennas or 3 dB coupler, this 1 is okay. Now, if you want to design a high accuracy coupler, then you need to select the layer 2 or the higher versions. So, but for antennas, the 1 is okay. So, just press OK. If you here see, it is showing us the details corresponding to the meshing part. So, the number of cells with the automatic edge cell and the minimum surface cells, this type of information is given here. Now, you need not to do anything else here, just press OK. If you see here, right. This is, you see here, the scheme is given that I have already told you, it uses some type of a scheme. The next is adaptive SMSA. This is a scheme which runs in the background of this particular software. So, this is a this uses multiple VCUs for to simulate the antennas. The next part is we need to define the frequency. Here, let us take it from 5 give the start frequency, then end frequency, and the number of frequency points. So, just you need to give the sufficient frequency points so that it should be able to calculate results properly by picking the frequency points. Let us take 151. If you see, corresponding to this, all the frequency points are given. One more thing I want to say, adaptive IntelliFit, it is given here. Now, if you see here, if you enable, if you check this particular option, it will pick some frequency point from this particular range and then calculate the corresponding fields and then extrapolate your data and then show you the results. If you enable this particular option, it will give you good accuracy with relatively less time, but if you disable this particular option, then it will calculate at all the frequency points and your simulation time will increase. So, this is how you will proceed. So, in this lecture, firstly we discussed about different types of software, and then we moved ahead towards i3D program manager, and then we designed basic microstrip antenna array, and then we make the polygon. In the next lecture, we will discuss about the post processing parameters like current, S parameter, VSWR, and gain, directivity, efficiency, and such type of parameters. So, thank you for this.